a survey found 60%, 40% read, 20% read both. If a person is chosen at random and if he find the probability that he also reads
0.3, 0.33.
0.33 in no, assume A and B as, so based on this, probability of A, assuming 100%, probability of A
3 by 5.
0.60, or let us make it 60, 0.60, right? Probability of B
0.4.
0.40. Probability of A intersection B
0.20.
0.20. So what we have asked to find? Probability of given B. We have to find the probability. He also reads Hindi paper, right? So probability that he reads Hindi paper, given that he already reads English paper, right?
Yes.
So what is the formula? Probability of A intersection B divided by probability of, we are finding A now, so this would be probability B.
B. Sorry.
A given B, right?
Yes.
What is the formula here? See, if it is B given A, then it is, see, I think you guys are getting confused. If you are saying probability of B given A is equal to, the numerator is same.
Where you have written B by A, that's where they confused.
Yeah, that's what conditional probability is a little bit confusing. This is probability of A. So what is the answer here? 0.20 40, right?
0.5.
0.50. If you want to find, we have the other probability also, right? Here we can calculate probability of B given A. That means probability that the person is reading English paper if he already reads Hindi paper. That also can be calculated because we have both the probabilities. In the earlier case, we didn't have. So this will be 0.20 divided by 0.
Yes, sir.
Yes, sir.
0.33 correct.
So in conditional probability, these are the two formulas. A given B has already occurred. Intersection A intersection B divided by probability B. Probability of given B given A has already occurred is A intersection B divided by probability of A. Now let us look at the Bayes theorem. This should be better. So Bayes theorem. This is the formula of Bayes theorem, which is a slightly expanded version of the earlier formula. Probability of A multiplied by probability of B given A has already occurred divided by probability of B. So Bayes theorem is the one popular theorem which is used in probability and statistics. So the other way of also looking at this is an important notation for data science. Probability of likelihood, posterior probability, prior probability, and evidence. So Bayes theorem is a conditional probability only, expanded version. Probability of A given multiplied by probability of B given A has occurred divided by probability of B. So this is based on previous historical data. So it is a method of existing predictions given new data or new evidence has come into picture. So using conditional probability to predict is the fundamental behind Bayes theorem. So first it will calculate the historical probabilities, and then whenever the new data is given, it uses those historical probabilities to calculate new probabilities. So that is the job of this Bayes theorem, which is a conditional probability, the expanded version of the normal conditional probability. So posterior, likelihood, prior, and evidence. These are the components. If you see here, the formula, probability of A given B is posterior, B given A is likelihood, probability of A is prior, probability of B is evidence.
Sir, can you please show the description? We need to write it down.
A, B, and C have applied are in ratio of 1:2. The probabilities A, B, change management in the company, change management to improve profits 0.8, 0.5, and 0. Respectively. If the change does not take place, the probability appointment. So 3 people have applied for a job in the company and the chance of selection are ratio of 1:2:4. The company is also expecting them to introduce change management to improve the profits. The probability of doing that, the probability of introducing change management in the company to improve profits are 0.8 for A, 0.5 for B, and 0.3 is for C. If the change does not take place, find the probability that it is due to the appointment of C. So in this case, first we have to define events. First define the events. E2 is B gets selected and E3 is C gets A is not happened. That is what the question is, right? So the question is, does not take place means changes are introduced, but profit does not happen. So probability 1 divided by 7. Total events is 1 plus 2 plus 4. Probability of E2, 2 divided by 7. Probability of E3 is 4 divided by 7. 1, 2, 4, right? And summation is 7. Probability of A given E1. Probability that not happened by changes by A is equal to 1 minus probability of profit happened by changes introduced by A, which is 1 minus 0.80, which will be 0.20. Probabilities that A and B can introduce change management to improve profits is 0.8, 0.5, and 0.3. Profit not happening by introducing by A is 1 minus profit happened by introducing of profit not happening if A is selected. Probability of A given A2 is probability of change introduced by B 0.50 is the 0.50. Given event 3 introduced by C 0.20, which will be 0.80, sorry, 0.30, which will be 0.7. We have to find probability not happening due to selection of, which is probability of A given E3 multiplied by probability of E3, probability of A given E1 multiplied by probability of E1, probability of A given multiplied by probability of A given E3 multiplied by probability of E3 is equal to probability of A given E3 is 0.70. 0.70 multiplied by the denominators are probability of A given E1 is 0.20 multiplied by 1 by 7 plus 0.50 multiplied by 2 by 7 0.70 multiplied by 4 by 7. So 0.70, 0.20 into 0.14, 0.50 into 0.28, 0.70 into 0.571 or 0.57, 0.711. Yes, Sujit, you are right. So if C is selected and profits doesn't happen, the probability is 0. Yes, you can take B in place of A. So you don't need to do this minus, you can take directly 0.80, 0.50 and 0.30.
Sir, how is it applied in decision science? Can you give a real-time example? How does it apply? Can you hear me?
Same thing, no? Which person to be recruited? If
Okay.
you have applied job and you have decided to apply to be recruited. All right, all of you got this? Now here, the probability that profit not happening due to selection of A. So probability of profit not happening if A is selected. Probability of profit not happening if A is selected. So if I copy this formula, E1 A E1, probability of E1, and the denominator remains the same. The probability of A given A1, 0.20, right? 0.20 multiplied by 1 by divided by 0.20 divided by multiplied by 1 divided by 7, 0.50 multiplied by 1 divided by 7, sorry, 2 divided by 7, 0.70 multiplied by 4 divided by 7, 0.05. Similarly, probability of if B is selected, so this is 0.50 and rest of all is same. 25% probability is there that profit will not happen if B is selected. Same thing what we calculated on top, we can also do it here if C is not selected. So A E3, probability of E3 which we given here, this will become 0.204/7. Oh, we got 0.2. Oh, sorry, this is not 0.20, no, this is 0.2, we got 0.7. So you can directly calculate if you know the formula. Brackets are important here. So this is how the bias theorem works. Okay, can we proceed? So bias rule in machine learning, where X is independent variable and Y is dependent variable, probability of Y given X has already occurred. Probability of X given Y has already occurred multiplied by probability of Y, probability of X. Probability of Y given X, probability X given Y, probability of X occurring given evidence Y has occurred, and probability of Y and probability of X, probability. So this is the formula if you have one independent variable. So Naive Bayes formula for multiple independent variables, probability of Y is equal to K given is equal to probability of X1 given Y is equal to K multiplied by probability of X2 given Y is equal to K multiplied by probability of given Y is equal to K multiplied by probability of Xn given Y is equal to K multiplied by probability of Y is equal to K divided by probability of multiplied by probability of X3 given multiplied by probability of Xn. Y is dependent variable, K is the number of n dependent variable, X3 tell theorem for multiple independent variables. So this is the formula for multiple independent variables, which is a real-time scenario. You'll have multiple independent variables and multiple levels in the dependent variable. The advantages of Naive Bayes works very fast and multinomial. So for both binary and multinomial dependent variable, this algorithm works and it works very fast in terms of prediction. Performs well when there is training data, and requirement of training data for modeling is less compared to other algorithms. More number of categorical email spam classification in text mining, recommendation systems is where Naive Bayes. So types of Naive Bayes in sklearn, if majority of independent variables, multinomial if dependent variable has if majority of independent. So this is the Naive Bayes which is there in sklearn Python, the three types of Naive Bayes: Bernoulli, multinomial, and Gaussian. Okay, we'll break and we'll come back and continue. Okay, please take your break and we'll continue after the break. So we have a data here. So in this data, the dependent variable stolen has two levels, yes or no, or two classes, right? Independent variables, three independent variables are there: color, type, and origin. The probability of car stolen, the color and origin is given. Color is yellow, type is SUV, domestic. So we are given this data. Now you have to find out whether the car will be stolen. So we have to find the probability of the car being stolen if it is yellow, SUV, and domestic. Now we have to create probability tables. Say yes, no, yellow. The first probability table for color. Now how many red cars are stolen? 2.
5.
Red and stolen, yes. Red and no, 1. Yellow and S. So column total is 5. Similarly, we also have to create the tables for the other two variables and what are the vehicles that are stolen. SUV and S, and SUV no. Oh, sorry, sports 1, 2, 3, 4. Sports and no. Okay, 2. Now we have to do the similar table for, so domestic and S, 1, 2, 2 domestic and S, domestic no, 1, 2, 3. Imported and yes, 1, imported no is 2. Okay, shall we start? Now we need to calculate two probabilities. Probability of yes, similarly probability of no. So basically is I probability, whichever class high probability, that will be the final class. So first we'll calculate this probability. Probability of yes given yellow, SUV and domestic. So probability of given yes, probability of SUV, probability of and probability of likelihood of evidence, which is the multiplication of all the three. Probability of yes, then finally probability of yes given yellow and domestic. Okay, guys, shall we continue?
Yes, sir.
So probability of yellow given S is equal to 2 divided by 5. Probability of SUV given yes. Probability of domestic likelihood of evidence is multiplication of all these three. 0.4, 0.2, 0.4. 5 no's and 5 yes. So this is 2 divided by 5. 1 divided by 5. 2 divided by 5. This is 0.4 into 0.2 into 0. This is 5 divided by 10. This is multiplication of 0.032 into 0.50. Now we have to find the probability of no. So highest probability is for no. The vehicle will not be stolen. All right, guys, all of you got this. So the probability of no is higher. So it will be final prediction will be no. All right, guys, we'll meet in tomorrow's session. Okay.